All right, hello. I'm going to try to answer a question about the density of water at different states of matter. I'm going to pull up a video, a website, excuse me. I'm going to show you how to pull it up because I find it very helpful. PET, P-E-T, this is the first one that comes up here from the University from Colorado. And I'm going to go to the simulations. You'll also be using this for labs this semester. So open the simulations corner, chemistry. You can see there's stuff here on biology, physics, and stuff. Check it out if you're taking those classes. There's kind of very visual things to interact with. There's a lot here. I'm going to go all the way down here to states of matter basics. You might have to update a macro or something, but should just load up into Chrome. So what we have here is kind of like a simulation chamber, and there's different atoms or molecules, and we're going to look at water. So we see we have a water molecule, a single water molecule. The red is the oxygen, and the white are the hydrogens, H2O. And we have solid, liquid, and gas phases here. There are two things we want to observe with each phase, and that is the distance the molecules are from each other and the speed the molecules are moving. So here in this solid phase right here, we can adjust the temperature. Let's adjust the temperature to Celsius, something we're familiar with. Negative 127 degrees Celsius, the coldest place on Earth. That's what that would be right here. Let's move it up to about negative 50 degrees Celsius right here. Okay? We want to note how slow the molecules are moving. You focus on any one molecule, it's just doing a little wiggle, not really moving that much. Okay? Let's just look at how slow they're moving. Okay? Now, look at the distance between the molecules. In space, in parts, there are big gaps, holes, you should say. Okay? Now I can pause it. All right? So look at this ring, look at this edge here. Okay? I want to notice a pattern of oxygen, hydrogen. See how that white hydrogen is pointing at the red oxygen, and then a white hydrogen is pointing at a red oxygen? This is an interaction that is very peculiar and fortunate for water only. And I say it's fortunate because this interaction of hydrogen bonding is something where this is the reason why people, when they look for life on other planets, they look for water, because of one of the peculiar things that water does. Here is a great capture of a white hydrogen and a red oxygen pointing towards each other right here. Okay? These are slow-moving molecules, and because of that interaction, they are kind of they're very ordered and rigid. Okay? When we go to liquid phase, let's move it up to 50 degrees Celsius. So this is a very warm cup of water. It's about 130 degrees. Okay? Look at how fast they're moving. They are moving much faster. They are tumbling. Some of them are making complete 180 to 360 degree turns. Okay, they're tumbling. And look how they are closer together. They are closer together. Water is more dense than ice. That is why ice floats, icebergs, Titanic. And because these molecules are moving faster, that hydrogen bonding interaction is not occurring. And this is very unique for water. Water is very unique in that the liquid is more dense than the solid. So between solid, they are slow and very organized because of this oxygen-hydrogen interaction. For liquid, they're faster and closer together. This is very unique. Finally, gas phase at about 150 degrees Celsius. So this is hotter than boiling water. This is steam. like in a pressure cooker or a crock pot. All right. See how fast they're moving. They're moving very fast. Some of them are tumbling very fast, and they're also moving a great distance, and they're very far apart. The distance between any two water molecules can be seen to be relatively very far apart. Thank you so much.